All right, so the last video I was just introducing this idea. Of course, this is what's called the greenhouse effect. Now, one of the things I should mention right away is the greenhouse effect is actually a wonderful thing for our planet. The water vapor and the carbon dioxide in the atmosphere keeps our planet relatively warm. We would, without the greenhouse effect, we would be sitting at about negative 18 degrees Celsius, which is really cold, right? We would be extremely cold all the time. And so some greenhouse gases are certainly absolutely necessary for life, for different forms of life on this planet. But see, what's happened is, since humans, going back almost 200 years, humans started to burn fossil fuels, and you can see over the course of time. So this is every 10 years or so, the amount of fossil fuels, or the amount of carbon dioxide. Okay, so there's other stuff like water vapor is by far the greatest greenhouse gas. It's way more effective than carbon dioxide, right? So why are we not worried about water vapor? Because water vapor will naturally come out of the atmosphere, right? The water cycle. But carbon dioxide does come out of the atmosphere, usually, in that plants plants and the oceans will take carbon dioxide out of the atmosphere. The oceans will dissolve the carbon dioxide, and marine life will turn a lot of the carbon dioxide into calcium carbonate, for their skeletons. But the thing is, we've put more carbon dioxide into the atmosphere than naturally happens over the course of history. We can take this is going back just 200 years or so, but we can look way back in Earth's history, when we take these samples of ice, in Greenland and so forth, and the deeper we dig the ice, we can find little pockets of the Earth's atmosphere, thousands, hundreds of thousands of years ago, and so we can tell that the amount of carbon dioxide has increased dramatically, and this is all due to humans. Right. I mean, there is carbon dioxide in the atmosphere due to volcanic activity that's been going on since the Earth was created 4.5 billion years ago. But in this last 200 years, it's grown dramatically, and this is what we would call an exponential curve. And this curve is not coming down anytime soon. Because modern society, we absolutely are completely dependent upon, everyone is. Now, I'm not, the blame is everywhere. From cars to coal burning, power plants and things like that. This is constantly increasing, and it's not just the United States. That's another point I should make. Countries around the world are using more and more carbon dioxide. I'm sorry, more and more fossil fuels as time goes on, and they are putting more and more carbon dioxide into the atmosphere. So I mean, this is. It's getting to the well. It's gotten to the point where this amount of carbon dioxide is changing the climate, the predictable weather patterns that we've relied on for many decades. It's completely changing. I mean, look at the number of hurricanes that are happening each year, and the extreme flooding that you find throughout the world, right? So the weather patterns are drastically changing, and the thing is, it is due to this increase in carbon dioxide that is just caused by humans. Now, there are some other things that are going into the atmosphere: methane, nitrous oxide, also some industrial activity adds ozone to the atmosphere. And then this has actually been banned by most countries. These chlorofluorocarbons, CFCs. One of the reasons is we learned a long time ago, back in the 1970s, that this stuff was causing causing holes in the atmosphere, or sorry, not holes in the ozone, which is of course in the stratosphere, and that of course is really dangerous to life, because the ozone is protecting many forms of life against harmful ultraviolet rays. All right, so this is overall, there is this warming trend, and we're noticing this as time goes on. The sea levels are rising, the ice is melting, the glacial ice is melting all over the world. And how bad is this going to get before we do something? I mean, I honestly think, this is just me rambling here, I think as long as the coal is there, as long as the fossil fuels are there, and it's economically easy to just use the fossil fuels, just like what got us started with using fossil fuels. They were easy to dig up, and you just burn the stuff and you get energy, right? So once that's gone, then humans will start to turn to have to turn to other alternative sources. Now we're already turning to alternative sources like solar power and wind power, but it's to a much less. We could not support the infrastructure is just not there to keep modern society to allow modern society to have the amount of energy that it gets from fossil fuels. We don't have that ability yet. Someday we might. Well, hopefully we will. All right. Now we'll turn to what happens with the wind, and I'm going to talk a little bit about pressure. And I'll do a separate video on pressure. We'll do some of the mathematics involved in pressure. So pressure is it's the force divided by the surface, divided by a certain amount of area, right? So all right. Anyhow, so the force of the atmosphere exerts on the surface area is what we consider pressure, and for example, in science, in engineering, we usually use what are called atmospheres of pressure. Like 1 atmosphere of pressure is the normal amount of pressure at sea level. And then, as you go higher, the atmospheric pressure goes down. And so the pressure where this force comes from is really just the weight of the air above, right? The air above is gravitationally being pulled down by the Earth's gravity, and that is causing a force across an area. And so the thing that really drives the wind is the fact that, and this happens every single day, different parts of the Earth are heated unequally, and so there's a difference in temperature in different locations. And so if there's a difference in temperature, Heat always flows. This is really important. This is like one of the laws of thermodynamics. Heat always flows from a hot source, a high temperature source, to a cold source. It just left to its own devices, heat will always flow from high temperature to low temperature. All right, so that's a basic law of thermodynamics, and that's going to be one of our guiding principles. All right. At any level in the atmosphere, the force, the total weight, so it's the total weight above, above what they talk about. Usually, people talk about a parcel of air. So it's like a column. You just imagine, just a huge column of air projected straight above a location on the Earth, and how much air is in that column. All right, I'll do some more. I'll do some actual examples, and we'll talk about that. So at higher elevation, there are fewer air molecules, so there's less pressure. I mean, that you might have experienced that if you climbed a mountain. Okay, so all right, so this is so the convection is when hot material moves from place to place. So a warm parcel of air will always rise. All right, so let me go over that a little bit. Why you probably heard that before, that warm air rises. Why is that? Why does warm air want to rise? So if you imagine, a balloon, right? A balloon like a hot air balloon, for example. I mean, the hot air balloon has, there's already air in the balloon, and if the air is cool, then or at the same temperature as the atmosphere, it doesn't, the hot air balloon doesn't rise. It doesn't go anywhere, right? But if you add hot air to the balloon, and you capture, of course, the hot air, the purpose of the hot air balloon is to capture that hot air. What happens is hot air, the air will spread out. It will move away from each particle of air will move away from the other particles of air because of this heat, right? They will spread out more, and when they spread out more, they are less dense. And since they're less dense than the cooler air around, in the atmosphere, they will rise. The hot air balloon rises. And by the way, the hot air balloon can only rise so high. It'll rise to the point where the hot air, the hot air inside, is when the balloon rises, it's the air in the atmosphere gets less dense as well, and so there'll come a point where the hot air inside of the balloon is the same density as the air in the atmosphere, and it won't rise anymore. Of course, the wind will can continue to push the hot air balloon. That's perfectly that happens all the time. All right, so hot air rises, cooler air will sink, and this sets up these. So now I'm not talking about a balloon anymore. I'm just talking about the atmosphere. This sets up this convection cycle. All right, and so just moving ahead here. I only got like a minute left. So one of the things that happens is, you have hotter air at the equator of the Earth, and then colder air at the poles, right, at either pole, and so there it sets up a convection current. But the problem is, the thing is about that is the Earth is spinning, and so these convection currents get altered in direction, according to what latitude. We'll get into that in just a little bit, okay? But the big thing is, when is there wind? The wind is when there's a difference in pressure. That's called a pressure gradient. When there's a pressure gradient, you get wind. The greater the pressure gradient, the stronger the wind.